And last video is power raised to a power. Of course, we're talking about the rules of integer exponents. So when you have a power raised to a power, you multiply. So remember when bases were the same and we were multiplying, we add the exponents. When bases are the same and you're dividing, you subtract the exponents. Now, if we have a power raised to a power, we multiply the exponents. So 2 to the third raised to the 6th power is 2 to the 3 times 6, which is 2 to the 18th power. That is very easy. It's like distributive property. Everything that's in there, you would put it to the 6th power. So even if we added a variable in there, find a pen. If we've added a variable in there, hold on. So if we said over here, I'll put it over here. We said 2 to the third raised to 6. Okay, 2 to the third power times a to the, we'll just say 1, a to the first power. So that's a 1. Raised to the 6th power would be 2 to the third times 6, 2 to the 18, because 6 times 3 is 18. And a to the, there's an imaginary 1 there, invisible 1. 1 times 6 is a to the 6th power. So it works for variables or numbers. But what it kind of looks like is like the distributive property, where you're giving it to each term inside the parenthesis by multiplying. When I say giving it to it, it's multiplying. Okay, so anyway, power raised to a power, you multiply. I can justify this, and this is the part that people forget about, is the justification of it. Why is it that you multiply it? Well, it's 2 to the third power 6 times. So 2 to the third, 3, 4, 5, 6. Whoops, did I put too many? 1, 2, 3, 4, 5, 6. All right, which we know 2 to the third is 2, 2, 2. 2 times 2 times 2. 2 times 2 times 2. 2 times 2 times 2, etc., etc. So basically, when bases are the same and you're multiplying, you're just adding 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That would be 2 to the 18th power. That's why it is. So when you have a power raised to a power, we multiply. Yes. So power raised to a power, multiply. When bases are the same and you're multiplying, you add. When bases are the same and you're dividing, you subtract. When you have a power raised to a power, you multiply. All right, so here I'm just showing you again, 2 to the third times 6 is 2 to the 18th. All right, what about when we have negative exponents? Does anything change? No. 2 to the negative 3 times 6. Negative 3 times 6. 2 to the negative 18th power. How would we write this as a positive exponent? We would say, remember that's very small, so 1 over 2 to the 18th power. That would be how to write it as a positive exponent. Okay, now again, if you want to justify, 2 to the negative 3 is 1 over 2 to the third. So remember, if we have a negative on top and we want to bring it below, we have to bring it below like that, and then it becomes positive. Okay, so 1 over 2 to the third 6 times is that, 6 times, which is 3, 6, 9, 12, 15, 18. 1 over 2 to the 18th power, very small number. It's a negative exponent, 2 to the negative 18th. All right, so again, when you have a power raised to a power, you multiply. That's it. 3 times 6 is 18, and negative times a positive is a negative 18. All right, so the rule for that, I decided to put it at the end instead of the beginning, is a to the n raised to the m is equal to a to the n times m. And remember, you can see multiplication as a star, a dot, or an X. And the reason I didn't use an X here is because I didn't want you to think it was NXM. So that's why we change our symbols as we go, because I didn't want you to think that was an X. So you could say N times M, N times M. But if I say N times M, might think that's an X. We don't want that. All right, so I just used my little asterisk right there, poof ball. And then you can also just squish them together when you multiply. A to the N times M. But normally when we're writing our math, whichever letter comes first in the alphabet, we put first. So LMNOP. So A to the M times N. Whichever, though, they're both correct. All right, so when we have a power raised to a power, we multiply. If we are multiplying exponents, we add. And dividing exponents, we subtract. Hope that cleared something up. If not, you can always shoot your instructor an email and say, hey, what's up with this? But I'll include these notes in Canvas. Enjoy.